Thank you, Yuri, for the invitation. About 1 month ago, we were introducing him in India as invited speaker, so we're changing roles now. So this is my favorite talk. I have been talking about this too much time. In June last year, the article based on this talk appeared in Communications.ecm and already has close to 10,000 downloads because people is interested in this topic. There are so many biases in the web and we don't know them. And the main goal of this talk is just awareness. So you know all of them. Maybe you know some of them, but not all of them. And then you next time you design a system, you take them in account. So this is what I want to talk about. And in this case, it's very easy because there's some causality help, right? But in the ACM article, they chose a very nice image that says, I'm right, everyone else is wrong. And that's the point, right? And in my case, it's true, but in other people's case, it's not. So before I start, let's define what is bias, because even the definition of bias is not agreed. And if you talk to a philosopher or social scientist or a statistician, you may get a different answer. So most of the time when we say bias and you study the statistics, we mean something like you had an experiment, you had something you want to measure, you get this nice normal distribution if you're, let's say, measure some human characteristic, and then you have this inaccuracy with the real value, and that's the bias. And this depends on the measurement systems, on maybe what the people is doing, and so on. However, there is also cultural bias. This is our upbringing, all our education, our culture, even our language biases us. Some words don't have a meaning in other languages, and so on. And the last one, the most complicated one in the sense that this is the most dangerous one, is cognitive bias. This is about you. Every person has their own cognitive biases. And you can go to the web and find things like this. This is like the 20 cognitive biases that screw up your decisions. There are like 100 too, so that depends on the table you want to use. But this one is very important. Number 7, confirmation bias. You see something that agrees with your beliefs, and then, of course, that is correct. Doesn't matter if it's fake news, agrees with your point of view, so it cannot be fake news. So there are several motivations for this talk. I would say one, I will go very fast, is inequality of content. So inequality of internet access, inequality on, say, languages. Here are some example, like we have a bit more than 7,000 languages now active, but less than 300 have a Wikipedia, and so on. For example, much more content in English than in other languages with respect to the size of the content. I will get back to that. I will give you some statistics. And most of the time, the content, and you know very well if you work in an internet company, I did for 10 years, the content is optimized most of the time for other purposes, not for really to please people. Yeah, we try to improve the user experience, but at the end, we are interested in the revenue, right? And of course, there is bias also in content quality. Huge distribution from good content to bad content. The second, and maybe this was the initial motivation from my point of view, what is the impact of this bias in search and recommender systems? So we know that most systems are optimized by implicit user feedback, clicks, and other interactions. And basically, these systems are right in the future. Because basically, you only can choose what these systems give to you. So basically, some clicks will happen, and other clicks will never happen. And I will get back to that later, because maybe that's the main bias today that we need to address. So we can have like self-fulfilled prophecies. I will talk about, say, ranking bias. Yeah, most people click in the first ranks. Why? Not only because they are good, also because they're in the first ranks. So if you don't debias that, you will basically fool yourself thinking that you are doing very well. And even maybe some systems are competing internally in a system. For example, every time the user experience improves the user feedback, the monetization teams says something wrong is happening. It's getting worse. And maybe they're not using the same optimization function. Of course, they're fighting each other and not really helping the whole world. So this is a classical thing that may happen in some companies. I hope not. You're using a single optimization function forever, whatever that is. And the third motivation came the year that I started giving this talk, and that was 2016, fake content. It was the time of elections in the US. A lot of fake news. There you have the 50 top in Facebook. Most of them were political. And then I like to remember this quote by Mark Twain attributed to this UK Prime Minister. Nobody knows if he really said that. But there are three kinds of lies: lies, damn lies, and statistics. I prefer to tell a joke. This is a statistician that had the head in the fridge and the legs in the oven, and they were both on. And then a friend really worried said, "Are you okay?" And the statistician said, "On average, I am okay." Of course, he was dead a while ago. And it's normal. I mean, everyone has biases. We live thanks to bias. We need to know where to look in the street not to be killed by a car, and so on. So we live by this bias. It's like entropy. But of course, some of them are not right. Okay, so this is the hypothesis. Any observational human data has bias. I say observational because we are not doing experiments with people, all right? So I will skip that part. And for example, here are some cultural biases that you can find in data. I will not read them. I'm sure you can guess most of them. This is just a small list. The main ones, maybe in ranking order, most important. And then you have maybe statistical biases, depending on how you get the data. And of course, you have cognitive biases. And here I will use just one for all of them. I will call it self-selection, your own bias. So many people extrapolate results from social media to other things that they shouldn't do. This was one of my motivations when I saw some papers doing this. Also, there are some people that don't want to measure bias, and other ones have a bias towards measuring it. So everything is a bias. And a lot of people during the Obama government started to work that at the government level, and there are very interesting two reports that are archived now, but you can get and see about big data and bias like 4 or 5 years ago. Now, this is an attempt to do an unbiased personal view of bias in the web. So it's not completely unbiased because it has my own bias. But let's say you take Twitter data. Well, Twitter data is gender bias, right? I'm sure there are more men than female. We can go down the street to ask them, but I don't know the number exactly. But the same with racial bias. I'm sure the fraction of people that is white is bigger. Age, I'm sure the people is towards like middle age. Social, economic, they need to have internet connection, smartphone. Most of them have high-level education, and so on. So all this is not a random sample of people. It's really a biased sample of people. So this is what I just said. So, for example, here there are like 6 possible biases of Twitter data. You know the bias, for example, Pinterest knows the bias of your own users. So what we are trying to solve is a non-technical question. It's not really a computer science question, but it's a very important question. You have biased data, you have an algorithm. Should the algorithm be neutral? Should the algorithm be fair? Even defining those questions is hard. But if you don't do anything, you get the same bias. So as many people say, garbage in, garbage out. And you don't even care because you got what you want, and you didn't even know that it's garbage. So part of it is garbage, part is not. The question is, which part is garbage? So as all difficult questions, it's not easy to answer this question. And here I like this cartoon about the difference between equality, equity, and justice. And for example, affirmative action will be one of these. But what we would like is to have the last one. Basically, we don't need to do anything because the system is already fair. So in this case, the answer is, as always, you have a complicated problem. The answer is not always. It depends. For example, if the algorithm is trying to detect bias, of course you cannot take it away, like in web spam problems. If maybe the bias is not important, relevant to people, maybe you don't care. But if the bias is important to people, may harm people, then you need to care. And then a lot of people today working on this, like the bias in the input, tuning the algorithm, like learning to rank with bias, or the bias in the output. I will not talk about this. That will be a completely different talk and will be like could be a 3-hour tutorial on that. This talk is about awareness. Next time you design a system, you at least know that you are doing something wrong. This is the idea. So, 2 years ago, the ACM, the policy committee, the US policy committee did a statement on the 7 properties an algorithm should fulfill. And these are the properties. I will not read them. The truth, today, there's no algorithm that fulfills the 7 properties. Even one is hard to fulfill. So maybe awareness is one. Maybe the system knows that it's biased, but it still is working. Accountability is very hard. Auditability. And last year, 2 conferences started on these topics, and by conscience, there's a bit of bias. The 2 conferences are happening this week in Hawaii and Atlanta. So they don't even coordinate themselves to have it in different weeks. So I couldn't go to the 2 conferences at the same time, so I decided to come here. It was much easier. So this is awareness. And there was some work like 20 years ago on this. So there are some people that talk about bias. The first paper that's very interesting was more than 20 years ago, but went, I guess, unnoticed. There were some people in machine learning looking at bias, but then didn't appear again until recently, let's say 5 years ago. And they're very important impacts in machine learning. For example, I know that no one assumes that things are uniform, but I think we have a bias to assume that. So, for example, we think that attributes will be like more or less the same in all the population, or we have a normal distribution. However, in the web, almost all the distributions are a power law, a very biased distribution. So that's one problem. Then we assume that maybe the errors in our predictions are uniform. I mean, how many papers do you see in machine learning that do error analysis? That says, okay, we can predict this with 90% accuracy and say plus minus 5% error. There are very few papers that do that. But for example, no one they say, okay, yeah, the error is 10% in the region that is interesting and 0% in the region that is trivial. Because usually these distributions are not uniform either. And I will talk a little bit about data sampling later. So let's start. Let's see all the possible bias in the web. So let's start with the obvious one, data bias, right? And I'm not talking about web spam. There are many papers on web spam. I will not talk about that. That's a particular bias that we need to fight. But we know about this. I'm looking at more subtle biases. Let me give you a sample of some data biases that I like. There are almost at least one per data set. So there are many. So this is a study we did for the Web of Spain. And here in the y-axis, we have exports from Spain to other countries in thousands of dollars. And here we have the number of links from the Spanish web, defined as all the websites in the .es domain, plus all the websites that have an IP address assigned to Spain. And then you see this almost a line. It's a log-log graph. You get a line. The correlation is almost 0.9, so very highly correlated. So there's causality. Of course, there's causality, not easy to prove, but there is a big correlation. Now, there are some outliers. And here I will show you this one. At that time, this was more than 10 years ago. This was the worst outlier, TK. Anyone knows which country is that one? Turkey. No, Turkey is TR. Turkey will not be there. It's not an outlier economically. Turkey must be around here. Okay, homework. Well, that country is in the same continent of this country, this country, this country, and this country. Yes. It's in the Polynesia. These are all the countries that sold the right to use their domain like FM to radio. Who knows which kind of country is FM?
Yeah.
Anyone knows FM? Country? It's related to the US. It's Federation of Micronesia. It's not Polynesia, it's Micronesia. This is part of the territory of the US. Well, if you take all these outliers that really are not doing economics with their domain, you get a larger correlation. We did a study in 5 countries where we got a good sample of the web. So we did it with the UK, Greece, also Chile and Brazil. And more developed the country, higher the correlation. So the links of the web are correlated to the economy of the world. So you have also cultural bias. Let's say you take one measure. I think this one is the size of web pages in websites in different countries. And you see this famous power law that is like the fifth law, the law of minimal effort. Basically, you have a lot of small pages and you have very few big pages. So this is nothing strange. This has to do with people. However, there is a very interesting law here that appears in every country, which I call the shame law. And it's the same law that allows us to pass courses. Basically, we do everything to pass, but also we don't want to be on the side of non-pass. So you do enough to do minimal effort, but also you do enough to feel that you passed. And this is shame. So for example, if you're writing an HTML page, you do enough to feel, this page is at least one screen is okay. So this, you see it in every country. So this is more like a cultural bias. And you can see this even in number of images and everything. And there's another paper we published on the analysis of many of these web collections. Let's change the topic. Linguistic bias. So there are several sites that have been trying to analyze the content of the web. There is a WS Tech that does 10 million websites. This one claims that if you take the top 1 million websites, and we can argue about which are the top 1 million websites because nobody knows exact traffic, that more than half of them are in English. I cannot reproduce the result, but I think they're more or less right. About half of the web, if you take the top 1 million websites, is just English. And of course, if you compare that to, say, the languages in the world, that's pretty biased because English is number 3 if you take native speakers. Of course, if you don't take native speakers, it goes to number 2. But maybe that's not the right reference for that. And that's very important. What is the right reference value? And this is a hard problem when you measure bias. Maybe we can use, for example, the top 10 languages in the internet. And okay, English number 1. But it's like less than 50%. It's like 20%. Maybe that's not also the right reference value. Maybe we need to consider the content of the web, and according to these statistics, it's 27%. But it doesn't matter what reference level you take, there is a bias. And the best one will be this one, where the factor is only 2. So there's twice more content in English for good quality than bad quality, which is good for all the people who speak English, right? Let me show you geo-bias. So this is from one of my PhD students, Eduardo, and these are news in Chile through Twitter, and you can guess that this is the capital of Chile. So these are things that are generated there and also consumed there. And that happens in every country. So here you get more news from Washington, D.C., only because it's the capital. So if you do any recommendation system with this data, what will happen? Basically, most people, doesn't matter where they live, these are all the other regions, they will see news from the capital. So in all recommendation systems, you have this geo-bias problem. In this case of the thesis, he did a system where he debiased this, basically showing more things that are local to the user, closer to the user, for example, from their own region. And in the wild, this user study with thousands of users showed that they prefer to have seen something like is local to them, which is not strange. And let me finish with some examples on gender bias, which are very interesting. So maybe you know this famous paper in NeuroNIPS now, or NeuroNIPS. So at that time had this name. So this is using news. And these people try to find she-he analogies. So basically, if you know how to call it in the female case, what would be the name for the male case? And they found this. For example, if she's a queen, he's a king. If she's a sister, he's a brother. And of course, these are correct. However, most of them were with gender bias. Like, if he's a nurse, she's a nurse, but he's a surgeon. Or if he's a superstar, she's a diva. And you know there's some negative connotations to the word diva. Now, I did some analysis. We say, well, what is the reason? In the paper was no analysis of the reasons. And I searched for who is writing the news. And maybe most journalists are men. And in the US, that's true. About 60 to 70% of the top journalists in the US are men. However, while doing the research, I also find out that at college, it's the opposite. Most of the students are women. So there's a big gender bias to find work in journalism, which is a completely different problem, but also interesting. Or we can have gender bias in translation. So anyone from Turkey here? Okay, you cannot talk. So I write, he's a babysitter, she's a doctor, translated to Turkish. I don't know any Turkish, so sorry. Cut and paste, and oh, she's a babysitter and he's a doctor. Come on. So why this is happening? Yeah, because like I guess in Finnish, in Turkish, there's no gender for the pronouns. So basically there's no gender here. And of course Google puts the most frequent case. She's a babysitter, she's a doctor. That's what the machine learning algorithm learned to translate. So be careful, don't do this. I mean, this is not transitive. And the best example also comes from the thesis of Eduardo that basically did a thesis about bias, is female biographies in Wikipedia. So these are sorted by year, and you see that there was a minimum that was, I guess, with the French Revolution, and after that, things have been improving. Égalité in French. And now they were like almost 25%, still far from 50%, but things are improving. So you can say, well, this is just systemic bias, nothing interesting here. However, there is something much more interesting here. That's history. I mean, gender bias was getting worse, and then maybe French Revolution, and then things started to change for women. But there's another bias here that will be obvious after I tell you, which is worse than systemic bias. Any guesses? Hmm? Hmm? Yeah, because there are not too many biographies in past history. So that's why the variance is higher. But that's not the point. No, the point is very simple after I tell you. The point is that there are very few women writing in Wikipedia. So, like, for example, for biographies, only 11%. And this number is biased because you don't have to tell your gender in Wikipedia. And maybe it's like 15% because some women prefer not to tell to don't get any trouble. But still, 15% is much worse than 50%. So please, for all the women here, write in Wikipedia. We need to put things better in shape. And there's a paper here you can get about gender bias in Wikipedia. There's another question that was more philosophical. Maybe there is no equal opportunity for women to be editors of Wikipedia. And that may be true in many countries. Okay, questions so far? That was about data. Just a sample of links, characteristics of the web, content, and so on. The next bias comes from us as a group. I call it activity bias. So basically, this is the whole bias of people doing things in the web. And most users are passive. Sorry about that. I don't know what happened. So users are passive, and for example, Pinterest will know how many users are active per day. Only every social media site knows that. But let's say 90% are passive, maybe more. So what happens if you take only the active users and you ask the following question? which percentage of the active users produce half of the content? So this is the question. This is like the democracy of content. And with another of my students, Diego, we look at this problem in 4 different data sets. A small one from Facebook, where we found that 7% of the people generated half of the content. We look at Amazon reviews, and we found a bit better that 4% of the people did half of the reviews. This is a very well-known Stanford data set. Do you have a question?
Yeah, sorry. Is it 7% of all users or 7% of active users?
Of active users.
So active users are the 10%.
Well, the 7% of the active users in this data set. But there's no data about the passive users because they're not in the data set. This is the problem. Too bad that we cannot log them, right? Well, when I saw these results in Amazon, I said, this is impossible. I mean, I cannot believe that 4% of the people are writing half of the reviews for free. Well, I don't know, Amazon read the paper, but 1 month later, they started suing fake reviewers. So, and then they continued this 1 year later because there was a problem. Most reviews are fake. So you need to be careful with that. And if you have like thousands of reviews, it's hard to fake them. But if you have 5, maybe they're all fake. And we did a bit more. We analyzed the quality of the reviews, and we used this measure called text entropy, and we found a correlation between text entropy and the helpfulness of the reviews according to the people. And then if we use the best 50% reviews, so basically we ranked the reviews by quality, this 4% went down to 2.5%. So it was more clear that very few people were writing the good reviews. And these are maybe most of them fake reviews. What about Twitter? Twitter is even worse. 2% of the people do half of the tweets. Nothing strange here. The reason is called ego. So maybe we need more people tweeting. All the other people just watch. And these are the active population. And here we had access to almost all Twitter in 2011, so these are real numbers. And the last one is a good one, Wikipedia. So do you know that 2,000 people wrote the first half of Wikipedia? They were paid. And thanks to them, maybe we have Wikipedia, because no one contributes to something that is half empty, right? We want to see like things like half full, and maybe a bit more than half full. So maybe thanks to them, we have Wikipedia. We cannot prove it now, but I'm sure that makes a difference, to contribute to something that is already there than to contribute to something that is empty. With Diego also look at other problem I was interested, that is called, what I call the digital desert. Basically, how much content in the web nobody ever sees. Like, for example, a blog. How many people outside the family read the blog? There are many blogs. Some of them we don't know, are like Polynesia. So here we have upper bound and lower bound. So the upper bound is from the Wikipedia data. There's a lot of interesting Wikipedia public data. And we found that if you take all the new articles and all the modified articles in 1 month, only 31% are looked in the next month. So this is an upper bound. Maybe the number is smaller, but depends on how much time we look. And then we have a lower bound from the Twitter data set. We find out that 1.1% of the tweets were done by people that don't have any followers. So I don't know if you understand how Twitter works, but this is like going to the Sahara desert and screaming. I don't know, maybe for each person it's a cathartic moment, but nobody is listening to them. So it's like this thing about if a tree falls in the forest and no one is there is a sound or not? Okay, I don't know. So that was about activity bias. Let's go now to the algorithms. So the algorithm takes some sample of web data and does something. Search, recommendations, whatever. E-commerce. The first problem is sampling bias, and the second is algorithmic bias. Here I'm using algorithmic bias for the bias that the algorithm adds. Some people use algorithmic bias for everything, including data bias. Here is something new. So this bias is new to the data bias here and the sampling bias here. It's something that the algorithm did wrong. You put a bias in the code. So let me give you some examples. So typically, when you use the standard sampling formula, let's say you are looking at clicks. If you take the standard binomial error, which is the formula square root of 1 minus p divided by n times p, this is relative error, not absolute errors if you see a different formula. Well, if you use this formula to estimate, for example, how many clicks you need to see to verify how much a given ad is clicked, you will get, for example, for something that happens 10% of the time, and you want a confidence interval of 80%, and a relative error of 10%, we need to use relative error because we are measuring some things that are very small. Then, if you use this formula, you will get that you just need to look at 900 clicks to measure something that happens 10% of the time. Well, you do that, you don't see the click, you assume that the ad is really bad. Well, but if you use the right formula, you need to see more than 2,000. And why? Because the standard formula diverges for probabilities that are very low. And there's a bias on all the statistics books to p equal 1/2. Because the statisticians like uniform distribution, and then the most difficult case for the uniform distribution is p equal 1/2. But we don't care about that. We are always working here. How many people here have ever seen a uniform distribution outside the book? Okay, I never. I'm still looking for it. So you need to use, for example, this one is much better. It's called the aggressive-cool interval, or it's called take 2. And this one doesn't diverge for 0, and it's much better, and then you get the right number. Now, this case is for something that happens 10% of the time. Imagine the difference if I give you now a real click value, like 1 in 10,000. Well, these numbers are like 3-4 orders of magnitude different. So it's very easy to get a sample bias problem. And I have used this for search, so I will not go into details, but basically you can use this with a stratified sampling. And for example, this is a perfect sample of just 130 queries from more than 100,000 queries. And you see that it's exactly the same shape. In the case of power law, you need to change the process of how to sample for the long tail. Otherwise, you don't get the long tail, because the long tail is really a flat thing. Okay, let me give you one example of algorithmic bias before going to say recommendation system, where we will find many more. But this is a typical case where you think you're doing something right and you are doing something really bad. And Rudolph must remember this, because this is a thing from one of his slides. So let's say you go to Flickr or any picture site, you upload this picture, and then you say, okay, this is London Eye, Thames, and then the system, very smart, have using correlative filtering and co-occurrence of labels, of tags, can recommend you other tags. And here are the recommendations, and then you click in the ones that are correct. What's the problem with this system? The problem with the system is that people will use it. So next time, I only put one label, because the system is very smart. Oh, deep learning, no labels. Why would we care, right? What's the problem? No new labels. You cannot learn any longer. The system needs data from people, independent data from people. So you have a folksonomy, please don't mess with the folksonomy. You need to live with the minimal work. So you don't want to recommend tags to people if you want to learn better how to label things. Now, of course, you can use this for search, but that's another problem, not to label. Okay, so let's go to the next step, interaction bias. You have this amazing recommender system. You put it in your website or in your app, and then you have people using it, and the people, of course, have self-selection bias. And let's see what happens here. So I'm sure you have used this site. I play tennis, so I was buying some tennis balls. How many biases we have here? Only the main ones. The first one, the most dangerous one, presentation bias. Some people call it impression bias. Anything that's in this page may get a click, for sure. Something that's not in this page will never get a click, right? So the rich will get richer, and the poor will get poorer in the click space. Now, we also have position bias. Why? Because in the Western world, for example, we look here first because we read from left to right and top to bottom. Of course, in China, they read differently, in Israel and so on, but still we have some cultural bias there. And we will look first here. We also have ranking bias. Why? Because we think that the first one is better than the second because we believe in the system. We have faith on us. But the truth is that many times they have almost the same relevance, right? Very hard to distinguish relevance anywhere. Social bias. I didn't like these tennis balls, and I want to put 1 star here. But I see most people put 5. I don't even know that these are fake reviews. So I said, well, maybe I've been too harsh. I will put 2. And then Vania comes and says, Ricardo, don't be so harsh. And I put 3. That's social bias. My original judgment has been changed by my social world, and maybe this happens more than you know. So we shouldn't know how many when we need to evaluate. And then we have other things that are interaction bias. For example, how many people will scroll down and click what is below this line? Almost nobody. Some people don't even know they can scroll. Have you seen now all these systems that if you don't put the mouse on the scroll bar, you don't know that it's a scroll bar? I wonder that the person goes there and finally, after a few weeks, finds, oh, there's something happening here. But before they didn't know. So people think that we know, but many people don't know. And the problem is that all these are related. It's not like independent system. So very hard to measure. For example, presentation bias will affect position bias. Interaction bias will affect the click bias, where you click. And of course, mouse movement bias. Some people cannot stop with the mouse. Some people cannot click often, and so on. Scrolling bias and social bias. So this is all connected. And of course, everything to the left is part of the system, but everything to the right is your own bias. So some people must read moving the mouse. I have seen them. Some people are eager to click. They have like anxiety to click. Even if we remember this research where if you put too many links, people don't click because they don't know where to click. So you can put less links. It's counterintuitive, but these things work. I will skip this. There was a paper on social bias about 4 years ago from IBM, but basically they show that if you start with fake reviews, then your product looks better than the other one that was honest and didn't do that. Ranking bias in web search. And this is maybe the first case where the industry acted on bias. It's click bias, because people click more on the top results. These are using eye tracking studies. This is 2005, and this is when Google introduced universal search, so you also have other types of results, and then people click in other places. But then this is what you see, more or less. If you have a click distribution in a search engine, you get something like this. Well, the top part is not really biased because these are navigational queries. This is lazy people. They prefer to say Pinterest search instead of putting Pinterest.com, right, and clicking the first result. But this happens. This is like 15% of the clicks. But then there is a huge bias here. And this is what is ranking bias. Also, we have some interaction bias. I'm still looking for the engineer in the first search engine, homework, which was the first search engine, the engineer that decided that we need to present the results 10 by 10. What is the rationale of that? But then you have, because of that, the next page has many less clicks. So if we put this in a log-log graph, you will get something like this. So you see that this is this interaction bias, and you see that the lines are not equal, and there are a couple of papers on the bias in that, most of them, I guess all of them from Yahoo Labs, that show how to get the right distribution if you didn't have the ranking bias. And recently, For example, there was a very interesting paper, was the best paper awarded Wisdom, of how to do learning to rank with bias. And after that paper, there are many papers on how to do learning to rank with bias. And this is a very interesting line of research. This is one paper where I contribute. This is about doing re-ranking after you do person search, so you get more females on the ranking than the standard result. Because if you say search a LinkedIn, you will get mostly males. Okay, enough for interaction bias, and then we'll go to the last part. Now we want to do the cycle. This is the final cycle. So this is what I call the second order bias, second degree bias. There are two types of it, the main ones. One is your feedback through the interaction that goes to the algorithm. There is a bias there. And the second one is basically what you do with the results of this algorithm and then what you put back into the web. So I will give you one example of each. Any questions so far? So how many people here read this book, The Filter Bubble? I'm sure there are many experts on this topic. It's related to personalization. For example, I know Vanya for a long time, so I could have a system that every morning predicts what he wants to do in the computer when he comes to work. But I will never be able to predict something that he doesn't know, that if he knew, he would like it. This is the filter bubble, or the tunnel effect, or the echo chamber. With qualitative filtering, we break this bubble, but if we have only data from one person, we cannot break that bubble. And this is very important because it's like the Truman Show. I hope many people saw this movie. So this person was very happy until he knew that he was in a bubble. And then natural reaction is to try to see what is outside the bubble. Now, not only we can use qualitative filtering to solve this problem, but also we can use diversity, novelty, serendipity. So I had a paper called Quasi-Orthogonal Recommendations. The editor didn't like the title, so at the end are orthogonal recommendations, which doesn't make any sense. But that's the idea. So you can present things that are slightly related and it still works. And there's a fourth solution that I haven't seen, but I would like to find this implemented. I call it my dark side. I want to see the person that is most different from me. For example, what news that person is watching. I will get scared, maybe, yes. But I will know something I don't know today, how far we are. What is the distance? What is the size of the universe in people? And I think that's something that the systems can help to us finding out. So of course we have a cold start problems there, and most people use explore and exploit. So the main problem is how much exploration is needed to really solve the problem of presentation bias. And the problem here is that investing in exploration means losing in revenue. So all companies do it in a limited fashion. Maybe they're not finding the optimal solution. You can aggregate in the tail, and that's the difference between personalization and contextualization. So personalization is like this. We take the data of one person, and we try to find the best for that person. But here we have the filter bubble problem. And also we have other problems. We have privacy issues. We have problems that in the long tail we don't have much data. However, if we look at the context, then we can do much better, because we can take all the people trying to do the same that this person is trying to do. Because this is not about the person, it's about the task. And tasks don't have so much privacy issues. And you will get more data and you will be able to do this. Let me give an example of something we did in Barcelona. This was and with people in Israel. And this was about finding basically routes in a city. So let's say we take a geo-tagged data set of pictures and we transform that to sequences of point of interest in a city. So for example, all of these lists are one person doing things in a city. And let's say now I go to Barcelona and I have 2 free hours and I ask what I should do in 2 hours. Well, we can take all this data and generate a recommendation path for that. So I can start in the Catalonia Plaza, and then go to the Cathedral, then go to the main market in the Boqueria, in the Ramblas, and then go to the Spanish Plaza, and then I can go to the airport because I have to go to the airport. So I can tell you how much time you will be in every site because I have the data. I can tell you how much time you will take from one site to another because also I have the data. And I can even tell you how many pictures to take. But that's over-personalization. You should stop at some point. Some freedom. Although some people say that free will doesn't exist, let's think that we have it.
You're missing the big cathedral.
The Gaudí. Yeah, the Gaudí, Sagrada Familia. Yeah, the problem Sagrada Familia is not in this map. So I have a bias to put things in the map. So Sagrada Familia is around here, so outside the map. But you can do that too. But then you have to do only that because you may do a queue, so it's not enough to work. You need to reserve via internet. Okay, let's go to the second case. You publish new content. Let's say you are writing your next blog entry and you do a query, you take results from the top 10, it's already biased to the ranking, these pages, you like these pages, and then you create a new page, you take the pieces that you like, you put it in your new page in the right order. Of course, you are not doing plagiarism, so you put quotes, the author, and link back to the source. Most people don't do it, but that's the right way to do. But of course, you feel some shame here because it's nothing from you, so you put some content. That's yours. Now you feel that you have done minimal effort. It's one page. And of course, you put your name because it's yours. This is the proud effect. And then you publish this back to the web. What is the problem with this? The problem with this is that this content is biased to what these search engines think is good. So it's not ranking bias because of position, it's ranking bias because of the algorithm that selects the content that is best. And in this paper that we published 10 years ago, it's called The Genealogical Trees in the Web, we found that about 35% of a big chunk of the web came from previous copies of the same web. So we had different temporal data sets to analyze this. This was 10 years ago, today may be worse, so who knows how much the web has been modified by these big search engines. So to end, this is not negative. The web works thanks to bias. Imagine if we have 100% active people. Imagine that all these people do uniform actions. The web will collapse. Internet will collapse. So thanks to this activity bias and self-selection bias, we can have a web that is much more workable, and especially thanks to caching. Even in a recent paper, we showed that, for example, 25% of the queries could be answered with less than 1% of the web pages. So it's really how people access content is really biased. So we need to be aware of our own bias. We need to try to break this vicious bias cycle. So maybe you can contribute in one of these pieces. And there are many research problems. So before finishing, I want to recap and ask a question here. So this is the main biases we have seen. These are statistical, cultural, cognitive, and I marked the ones that are of each type. But what about algorithmic bias? Let's say if I give a group of female and a group of male the task of writing a recommendation system, do we have that gender bias in the code? Or will you have like a different bias in the code? And this is an experiment that hasn't been done, but a very similar experiment has been done, and I think the answer is yes. The systems will be different. So this experiment was done in 2015 in the University of Virginia Center of Open Science, and they asked 61 people divided in 29 teams using all the data of the Champions League, that's the main soccer club competition in Europe, if basically colored people will have more red cards than white people. So basically if there was racism in the games. Well, 20 groups said yes, there's a bias. there is racism. 9 disagree. They couldn't prove it. This is already interesting because they didn't agree. But what is really interesting for me, and there is a report of 65 pages about the experiment done by psychologists and sociologists, is that statistically, the 29 teams did something different. So these are the 29 teams. This is basically the confidence interval. This is the value of the hypothesis test. This is equally like it. For example, this one was the one that was closest to prove that was racism, but the confidence interval was so large they couldn't prove it. This one, I don't believe they don't have a confidence interval. I believe they didn't know that you can have a confidence interval. So this is what I find amazing. There's a professional bias. When you look at data, you use your biases when you're doing the analysis. So next time, maybe you need to try in a different way. So for example, whenever you have a big problem, you ask the problem to be solved by 3 different teams, if it's really important for the company. Of course, the 3 teams will come with different answers. And then you put all the teams together until they get a 4th different answer. And then you have to cross your finger that that's the best answer you can get. So this is a real problem today, and it's not military robots. Because if we don't do things right, we will get to this. And not because the robots will kill us, it's because we will kill us. So very important. The robots don't do anything. We say what the robots do. So, questions?
Okay, thank you very much. We have time for questions.
Yeah.
Where do you sort of see the bias sort of fitting into the larger Universidad departments? So, for example, one way to address self-selection bias is to sort of have more diversity in recommendations. But then that leads to the same sort of like the way that YouTube led videos to be more extreme over time and put people toward conspiracy theories. So there's trade-off between decreasing bias in some sense or decreasing self-selection versus increasing some other bias.
So the question is about what we can do to basically diminish this bias. So this is the key question. So you are asking the key questions in a different way, more specific, but this is the key question. So what is the right way to address this? And I don't think there's a single answer. I would say that if we at least try to be fair with what we are learning, that's the first step. So basically, we can do more bias or less bias, but the question is, what is the right thing to do for the people if they didn't have that bias? So that means doing more random experiments. So basically, trying with systems that have different biases and see how people react and try to find what is fair for them. This is why, like, in some sense, democracy, but even democracy is not working in some countries because they are being manipulated. So I think you need to ask Harari, that would be very negative, or other people to answer that question. Because from the point of view, I would say at least try to design a system that you consider all the biases and you think you are being fair to the people that will be affected by those biases. So this is why I want to be people aware of all these things, because most people don't care about what some, like the second order bias. I don't think no one is addressing that. Yes?
That leads into my question. How do you even measure second order bias? So, like, you could think that the rise of search engines might have played a part towards the consolidation of web pages and like web companies. Like, how do you even start to measure something like that?
So we measured that because we found that 35% of the pages had pieces of pages that existed before. So imagine that today is 50%. If we continue, then basically, why we need the web? It's not growing. It's not having new content. So I think we need to have the right incentives for people to create new content. But, for example, could be like the editor, we're not allowed to paste more than 2 pieces of other places. Like, we need the systems to be smarter and make us to work. Because one bias we have, all of us, is this law of minimal effort. We want to work a little and get as much as we can from that work. So we need the system to be smarter. For example, things you can do, put things in context. For example, you're writing something. Okay, there are other views for that. Can we have automatically other views? If I'm looking at news, can I see where I am located if I'm looking at political news? Or maybe I'm in the extreme left or extreme right. I will be worried. I'm becoming an extremist. So I will try to move to the right or move to the left. I think we need the systems to put us in context, and I think that's what is missing. The systems is like, for example, why people search with 2 words? Because we are lazy or because systems taught us that 2 words work? Well, it's both ways. It's a system that fulfills itself. We need to break these fulfilled prophecies. So the systems need to help us to do that. Yeah.
That's one of the best presentations I've seen on bias, because bias has, as I believe, is going to show up in our dreams because the vibration of bias is there. I like your presentation because you have very good understanding of bias. It's one of the best presentations I've seen. I wanted to ask you if you were to have solved the problem of bias, whether it's gender or qualitative or quantitative data. There is no solution because human beings are social animals because we are not perfect. We have the way we see our mirror, I'm mad, I'm a human. But I think if you want to solve the problem of bias, you have to live in equanimity. You don't actually, you are not this or that.
So thank you for your personal bias. And if I can quote yourself later, maybe my ego will be happy. But I think that the solution comes, I think there are 2 levels of the solution. So there, and it's many cases we're working. So we have individual bias problem. So how to be fair with every individual. And also we have the problem of how to be fair with the group. And like in many difficult problems, it's very hard to be fair with both cases, like the individual and the people. So these things are society issues that we need to solve. And as in many other cases, technology goes too fast, and things like ethics and fairness go too slow. And I hope someday we get closer. But that's my personal bias.
Great. So let's thank Ricardo for the talk. And then everyone is invited for dinner and drinks in the room behind here. We will reconvene in about a month to have a talk by Emma Brunskill about reinforcement learning. Thank you for coming.